Hello and welcome to the Innovations Lab. This is Matthäus, he is helping me today, and I'm Andreas Straube. I'm professor at the Rosenheim Technical University of Applied Sciences, and you are here in the Innovations Lab. We would like to introduce you to some new technologies, and let's start over here with 3D scanning. So here we have a 3D scanner we use for our students to learn about the technology. So the theoretical background is being taught. So for example, we have here some VCSEL projectors projecting infrared patterns being detected by stereo cameras. One is here and one is here. By this we can reconstruct a 3D object. And furthermore, we have this camera here which is picking up the color of the object. And we use that in student projects, for example, to scan parts of a Ferrari engine from 1951 with one of our industry partners. Then we assembled that to a virtual engine, and we were able to show that in the virtual reality environment, which I will tell you about later on. Next technology is also a 3D scanning technology, but this time for bigger objects. The one I showed you was for 1 cubic meter, and this is for complete houses and buildings. So here we have a rotating mirror. You can see the surface here. And it's throwing a laser light into the room while the camera is rotating like this. And by this, the whole room is scanned. Furthermore, we have a camera here taking 360-degree pictures. And then this is put together to a digital twin of a building. When going to our website, Campus Chiemgau at TH Rosenheim, you're going to see a digital twin of this building and also of our lab. The next technology is additive manufacturing. And let me show you this part here. It's a piston from a Ford Model T from 1914. And students scanned this, and afterwards we printed it. So, and here the orange part is the printed part. Look inside and look here. And you might ask yourself, what is that white stuff here? The white stuff here is support structures, because here we have a piston ring, and it would fall down if we just printed in air. Therefore, we have that support structures. They are built in a natural way, so it's called a tree structure, that helps us to reduce the material being used for the support structures. We move on to the next technology, which is our collaborative robot. And you can see that we have some 3D printed parts here for the gripper, for example, and here the pallet for our parts. These are little shafts we use here, typical parts from mechanical manufacturing. And Matthäus, could you start the program to show what the program is doing? A very simple program for palletizing. The cobot going to go for the first position of the pallet and take a part, grab it, and then move it over to that bin. And on this screen here, you can see the program flow. We're currently at point number 1. Now we are detecting a landmark. Then we're going to the pallet function. And from there, it's picking another part and bringing it to the bin. So this technology of collaborative robots allows you to work with robots without a safety fence. And this makes it attractive also for smaller companies because the program is visual and you have less safety restrictions. We move on to the next technology, which is the measurement technology. We use it for this part here. It's a shaft from a gearbox. And we want to measure those 2 diameters here, which have a very tight tolerance of 10 micrometers. And for this, we put the shaft into the fixture like this. We have inductive probes over here, which have a resolution of 0.1 micrometer. That means 1 millimeter being cut into 10,000 pieces. You add up with the tenths of a micrometer. The sensors are going to our electronic unit at the back, and from there being fed into our computer. And here we have a display screen for the operator. You see the diameter was good. You have a green bar. You see the last diameters being measured, and you also see a histogram so the distribution of the measurements we have been taken, and there you can already guess that we're going into statistics here of production parts. We move on to the next technology, which is augmented reality. Here we have a flyer for our first study program, e-commerce. All our study programs are involved with digital transformation, and you might ask yourself, why are you using paper flyers? But there is a digital input on the backside. If we scan this QR code, we will get to our professors. They're standing then on that flyer. So if I'm rotating the flyer, then the professor would be rotating. And if I start animation, the professor's gonna rotate with the flyer and start talking about the study program. And this is augmented reality in 2D, but we also have augmented reality in 3D. For this, we're using those glasses. These are the Microsoft HoloLens glasses, and you can see they have transparent displays. I open the glasses like this, put it into my head, and tighten it. And now you can see my eyes through the glasses, and I can see virtual objects floating around. Oh, look here, there's a little fish. If you follow my view on this screen, you can see what I'm looking at. And here, there's a little fish in the room. So I can take the fish and move it up. I can rotate it. And I can also interact with the glasses menu. So here you see a little Windows icon. So if I click the icon, a menu is going to pop up. And then in this menu, I can operate a program and download some files. So here's a library, and let's download this file from the ballerina. The model is being loaded, and now we have a little ballerina here, and I could put it on the camera, for example. And when walking around the camera, you can see how the ballerina is standing on top of the camera. And we use that to create guides to teach people in production, for example, how to use a certain device. Our student made guides from our 3D printer, but also from our measurement station. And you can watch those guides on our YouTube channel to get an idea of how that works. Next technology is this glass here. It's a MetaQuest 3S glass, and it is a virtual reality glass. So you can see no transparent displays. Instead, there is a little screen inside and a complete computer like a smartphone. And we're wearing it by putting this on, then tightening the head strap, and then you are in the virtual environment. And in this, you could see, for example, the Ferrari engine I just mentioned in the beginning. It will be standing in front of you. 4 students can wear the glasses. They all see their perspective on the virtual engine. One is the guide, usually that's me, and I'm taking apart the engine, explaining all the detail of that engine. Very impressive is the explode mode, where I can explode all the parts so the whole room will be flooded with the parts of the engine. Next part is also a mixed reality device. It's the Apple Vision Pro I have here, and I have to be a little bit careful because this part here is actually magnetic, so you're not supposed to carry the glass on this part. There's an external battery I have to put into my back, and then you can open the glass here and put on the glasses like this, tighten here, and it's a mixed reality device, so I can see the environment here, and I see a little window here, and then I can interact with the environment similar to the MetaQuest 3, but with a much better display quality. Next technology is, in this case, artificial intelligence, and we prepared a part for training a neural network. Thank you. It's from the company DH Electronics. It's a local company producing those devices for home automation. And you can see we have those little parts here, which are setting the devices, and they are placed manually, and you could misplace them, so quality would be bad. Therefore, we give those devices to our students. They have to take pictures of good and bad parts, and then use that to train a neural network. And Matthäus is showing us how that works. So we have a webcam. Matthäus, would you point to the webcam? Yeah, and the webcam is taking an image, and the image is shown on the screen, and where we have that colored boxes, these are detected objects. So if Matthäus removes one part, you see that at the place where formerly there was a box detecting it, now it's recognizing that the part has been taken away. So that's it for today, the short introduction to our lab. We're adding new technologies from time to time, and we hope to see you here in person one time. So thank you for joining, and bye-bye.